Assalamualaikum everyone, myself Jahid Hassan Tor. Today is our digital logic circuit presentation. Our presentation topic logic based password protection system supervised by Nafiz Ahmed Chisti, section E. We make our presentation by 5 group mate me Jahid Hassan Antor, Ghulam Kebriya, Talukdar Hasnat Javid, Mutasir Alam Oyon and MD Abdul Aziz. Me introduction part. In our increasingly digital world that need our source access to personal and sensitive information in undeniable, many systems and devices require password-based authentications and grant access for smartphone to bank ATMs, ensuring that only authorized individuals can gain entry in scriptural consent. Traditionally, password protection system really and software-based solutions often integrate into operating system and applications. While effective, this system can be valuable to various threats, including hacking, malware, and software vulnerabilities. As the result, there is growing interest in exploring hardware-based password protection system that can be provide an additional layer of security. Their project develops into the realms of hardware-based password protection, specifically forcing on using digital logic circuit and components to create a robust and reliable system by shifting the security force for the software hardware. We aim to explore novel approach to password protection that can resist common software-based attacks. Project objectives: develop hardware-based password protection. Create a password protection system using digital logic circuit. Enhance securities. Strengthen security by mitigate software-based vulnerabilities. Integrate digital logic principles. Apply digital logic to craft and effective security solutions. Demonstrate, provide applications, showcase real-world cyber security solution through logic concept. Methodology and modeling. This section provides an overview of the methodology and modeling technologies employed in the development and implementations of the logic-based password automation system. Describe this project. It outlines that systematic approach used to design, simulate, and construct that system, emphasizing that logical components and their interact. Now I invite Ghulam Kebriya to upcoming presentation. Thank you everyone.
Thank you, Jahid Sanantor. Myself, Ghulam Kibriya Himel, Department of Computer Science and Engineering. Now I am talking about working principle of our project. User input and initialization. The user enters a password through an input interface such as DIP switch. During the initialization phase, the current password is stored in the system of another DIP switch, which is acting like a memory. Password comparison using digital logic. The entire password is in binary form, consisting of a sequence of ones and zero. Digital logic gates and circuit are utilized to compare each bit of entire password with the corresponding bit of the stored password. Bitwise comparison and decision logic. The bitwise comparison result determine if each bit of entire password matches the corresponding bit of the stored password. The decision logic evaluate the overall comparison result to determine if the entire password matches the stored password. Authentication outcome. If all the bits of entire password match the corresponding bits of the stored password, the system gets authenticate and access. If any bit does not match, the system denied access and authentication and counts the number of wrong password. Hardware level security. The security strength lies in the hardware based implementation using digital logic circuit. Hardware level security provides resistance against certain software based attacks and vulnerabilities. Redundancy and error detection. Redundancy can be implemented using priority or error checking based on enhanced security and detect potential error in the entire password. Response and feedback. The system provides immediate feedback to reader regarding to authentication outcome. Visual indicators such as LED can indicate whether the authentication was successful or not. Green LED is for correct password and red LED is for wrong password. Alarm and the use of JK flip-flop. Using JK flip-flop in digital security system is a common practice for counting incorrect password attempts and enhancing security. Each incorrect attempt triggers the JK flip-flop to increment a count. When the count reaches the predefined limit, typically 3, it triggers an alarm or security response. Discouraging an unauthorized access, resetting the count 0 occurs upon entering the current password. Preventing continuous counting, this approach adds an effective layer of security by limiting password guessing and ensure or means for authorized user to reset the system after a alarm is triggered. Flexibility and customization. The system can be designed to accommodate password of verifying length or complex requirement. Digital logic circuit allow for flexibility in handling different input scenario. Real-time processing. The authentication process occurs in real time, allowing the quick access decision based on the comparison result. Integration and the application. The password security system can be integrated into various applications such as electronic lock, access control system, and digital device requiring security logging. Thank you everyone. Now I would request my groupmate Talukdar Hasnat Jadid to represent the next part of our presentation.
Hello, assalamu alaikum everyone. I am Talda Aslam Jadid. I am going to discuss the part about the simulation part. So here in the simulation setup, we have used components which are deep switch, resistors, jumper wires, buzzer, logic gates, capacitor, 555 timer IC, JK flip-flop, LED, push button switch, and in the last part, that's power source. In the first part, deep switch, we have used component to take the input of the password. With the resistors part, they were employed for current limiting part and pull up, pull down configurations. In the jumper wires, we use jumper wires to establish connection between components. In the buzzer part, it was used to integrate to provide auditory feedback on the authentication status. With the logic gates, we employed these gates to implement the comparison and decision logic. In the capacitor part, in this some cases, a capacitor was added for timing and noise filtering. And 555 timer IC, we use this part to utilize this IC to generate clock pulses for this circuit. In the JK flip-flop, the JK flip-flop was used to store and manage authentication status. In the LED parts were incorporated to offer the visual feedback on the authentication status. With the push button switch, this was used for system reset or manual control, and power source was a stable power supply was provided to the circuit to ensure its proper functioning. So in the On the next part, it's about the functional validation. Inputting the correct password was validated to confirm the system granted use and access and provided positive feedback. And on the other hand, we used incorrect password, which was tested to ensure the system denied access and triggered appropriate feedback. The system's behavior are tested with various password lengths and combination to assess its robustness. Timing accuracy of 555 timer IOC was measured using an oscilloscope or a timing diagram. In the documentation part, we can say that clear circuit diagrams, schematics, and connection layouts are created, and comprehensive records of test results and observations for each scenario were diligently maintained. So in the next part, my other teammate Muntasir Moyan will describe about the other parts. Thank you so much.
Hello everyone, this is Muntasir Alamayon and I'll be describing the simulation of this digital password security system. So first off, we use DIP switches to insert password as input and also set password. We used XNOR gate to compare them because we know the output of XNOR gate will be 1 whenever the two inputs are same. We used AND gate to implement the correct password logic and NOT gate to implement the incorrect password logic. We also use 555 timer to generate a clock pulse and the JK flip-flop to store the authentication status, which in this case will store the number of attempts that are being made. So first off, suppose we set our password to be 10101. Then if the entered password matches with the set password, then the green LED will indicate that the password is correct. Similarly, if we enter a wrong password, the red LED will indicate the password is incorrect. So like this way, every time we enter a wrong password, the counter will count it and display it on the DCD hex displayer. And if the count reaches to 3, then the buzzer will start vibrating and the red LED will start blinking, which will result in the system to be reset so that we can set our password once again. And that is all from my part. Thank you so much.
Assalamualaikum sir, I am Abdul Aziz from section E. I am going to discuss about the limitations of the project. Limited complexity. The project's hardware-based approach may impose constraints on the complexity of the authentication process and security features due to the available digital logic components. Fixed password length. The system's design might need a fixed password length, potentially limiting flexibility in user-defined password lengths. Hardware constraints. The circuit's complexity might be constrained by available components, affecting the ability to implement advanced security measures. Susceptibility to physical attacks. Hardware-based system may still be susceptible to physical attacks such as reverse engineering or component manipulation. Learning curve. Understanding digital logic and circuit building may pose a learning curve, especially for those who new to electronics. Limited feedback. The system's feedback mechanism might provide limited information, making it challenging to diagnose issues. Conclusion. In conclusion, the logic gatekeeper logic based password authentication system has been successfully designed, implemented and tested. This project has demonstrated the feasibility of creating a secure and cost-effective password protection system using digital logic circuits and components on a breadboard. Throughout this project, we have achieved the following key outcomes: system design, implementation, functional validation, safety precautions. The project was a hybrid of both sequential and combinational logic. This project has many future endeavors, such as user interface, incorporating a user-friendly interface such as an alphanumeric keypad or touchscreen can enhance usability. Advanced encryption. Implementing more advanced encryption techniques to store and verify passwords can further enhance security. Biometric integration. Integrating biometric authentication methods such as fingerprint or facial recognition can provide additional layers of security. Remote access. Exploring ways to enable remote access and control of the system, possibly via a mobile app or web interface. Machine learning. Implementing machine learning algorithm for anomaly detection and adaptive security measures. IoT integration. IoT capabilities for remote monitoring and control. Open source development, open sourcing the project to encourage collaboration and innovation in the field of digital security. We need many informations for this project, so we used these reference points for the completion of this project. Thank you very much, sir, for listening to our project and giving your valuable time. Thank you so much.